Welcome to this tutorial on bellman algorithm. So in this session, we'll explore how this algorithm helps find the shortest path in graphs even when there are negative edge weights. The bellman algorithm is especially important because it can detect negative weight cycles unlike other shortest path algorithms. So we'll cover the concept step-by-step simulation and show you how it works with code. The Bellman-Ford algorithm is a graph algorithm used to find the shortest path from a single source vertex to all other vertices in a graph. So it works with weighted graphs and is particularly useful when the graph contains edges with negative weights, unlike distress algorithm, which cannot handle such cases. So the algorithm also detects negative weight cycles, ensuring that solution exists if the graph does not have such cycles. This algorithm says that you're going to relax all the edges n minus 1 times. So what is n here? So n is the number of vertices. Number of vertices here is 4, so we should relax them 4 minus 1. So the idea here is from the source vertex to the longest maybe of edge, there can be 3 maximum of edge. So we will relax it to the maximum of 3 as the longest. So what's this relaxation means? So if I take 2 vertices, so let's say 2 and 3. So let's call it U and V. Then between a pair of U, V, there's an edge. Then check if the distance of U plus cost of an edge, U, V is less than distance of V. If so, then change the distance of vertex B to distance of U plus cost of an edge, U, V. So, madali yan, mas maintindihan natin yan dito. So, to start relaxation, we need to prepare a list of edge. So, pipili tayo ng source vertex natin. So, para mas madali siya, we'll select this vertex by vertex and we'll start with vertex 0. So, we have total of 5 edges here. So, we will relax them 3 times. So, initially, we need to mark the distance of all the vertices. So from vertex 0, let's say this is distance is 0 because it is source, so it will start with 0 and then all other remaining vertices is infinity or infinite. Okay, infinite. And now we will start relaxing all edges. So first edge is we have the 0 to 1. So what is the distance of 0? 0 is 0. What is the distance of 1? So 1 is infinite. So 0 plus 4 is plus 4. So we will change that to 4. And then next edge is 0 and 2. So 0 is 0 and then 2 is infinite. So 2 is less than infinite, so we'll change that to 2. And then third edge is 1 and 3. So 1 is 4 plus 3 is equals 7. So 7 is less than infinite, so we'll change that to. Then next is 2 and 1. So 2 is 2 plus 1. So 3 is less than 4. So we'll change this 4 to 3. And then last edge, we have 3 and 2. So 3 is 7 minus 5 is equals 2. 2 is not less than 2. So we will change. This will be no changes. So now that we relaxed it first time, 2 more times to go. So meron na tayo 92 changes. And then in second iteration, first edge 0 plus 4. 4 is not less than 3, so we will not change that. Then second edge 0 and 2. So 0 plus 2 is equals 2 and 2 is not less than 2, so we will not change that. And then second iteration, third edge, so 3 and 1 and 3. So 1 and 3 is 3 plus 3 equals 6, so 6 is less than 7, so we will change that to 6. And then fourth edge, so fourth edge not plus 2 and 1, so 2 is 2 plus 1 is equals 3. 3 is not less than 3, so we will not change that. And then in fifth edge, we have 3 and 2, so 3 is 6 minus 5 is equals 1, and 1 is less than 2, so we will change that to 1. And then we were here in final iteration or third iteration. So second edge or third relaxation, so this is the last relaxation. So first edge is the same, 0 plus 4 is not less than 3, so we will not change that. So 0 plus 2, we will not change that. 1 and 3, so 0 and 3 and 3, 6, we will not change that. 2 and 1, so 2 and 1, so 1 plus 1 is equals 2, less than 2 is less than 3, so we will change that. And then 3 and 2, so 3 and 2 and 2 is 6 minus 1 equals 1, so 1 is equals 2, so we will not change. So now that we completed the relaxation, we got the result of vertex 0, distance of 0, and then vertex 1, distance of 2, vertex 2, distance of 1, and vertex 3, distance of 6. So kahit ulit-ulitin mo siya, yung vertex, yung result na yan is hindi na siya magbabago. So yun na siya. Now we will proceed to programming. So we will be using Python as our platform. This can execute the bellman Ford algorithm. So first, we define a function called bellman Ford with a parameter of graph, vertices, and source. And then we have to initialize the distance. So the distance, we will initialize variable distance with a value of float inf times vertices and another distance source equals 0. And then we have inside this function we have relaxation steps. So kanina nabanggit ko din kanina, no? We have to relax all the edges n minus 1 times. So to make that in programming, we will use for loop. So for loop, and then in range function, which is vertices minus 1 to get those n minus 1 times. So vertices minus 1. So dito sa baba meron tayong variable na. So dito sa baba meron tayong vertices variable equals 4, which is yung vertices natin is kanina is 4, 0 to 3, and then ang source natin is equals to 0. So every iteration is meron tayong nesting for statement ulit. So for u, v, w in graph. So yung u, v, w in graph is ito siya. So since meron siyang tatlong parameter, so it will get those 3 parameter sa graph na ginawa natin dito. So u stands for first vertex, and then v is the destination vertex, and then w is yung weight ng edge. So after that loop, so meron tayong dalawang loop, nested loop. So if distance, every iteration is meron tayong condition na if distance u not equal float inf and distance u plus weight less than distance v. Then papalitan natin yung value ng distance v ng distance u plus weight. So yung kanina, yung dinemo ko kanina about kung paano siya napapalitan or paano siya nare-relax is ginagawa dito ng program. So, and then after that, magpiprint siya ng shortest distance from source and then comma yung distance. So, if you run this, ito siya, no? Kailangan muna natin i-call yung function para mag-execute siya. So, we will get the text shortest distance from source, and then meron tayong list dito na 0, 2, 1, 6. And that's all. Thank you.